as well as a convex lens. And we have also seen regarding the formulas, the mirror formula as well as the lens formula. What is the mirror formula? 1
upon B
minus
1 upon
minus. Is it minus or plus here?
Plus.
Mirror is plus. Plus
is
1 upon
is equal to 1 by. Here
1 upon
B
minus. So you have to remember that it is lens. If you remember it is negative, here it is going to be positive. Okay. Similarly, magnification. What is magnification? Magnification. B upon B upon correct. H dash upon H0 is also correct. Okay, correct. But for mirror formula, it will be negative. Here it will be positive. For lens, magnification will be M is equal to H dash upon H0, which is positive. Okay, or even B upon E, which is going to be positive. Here it's going to be negative. So those are the little things that you must remember. The rest of the thing is going to be pretty easy. All that they are going to give you is the object is placed here, find out where the image is formed. Okay. Remember, if it is a real and inverted image, what does it tell you? That it can be caught on the screen. The moment you see that it is a real image, we know that it can be caught on the screen. But a virtual image, of course, cannot be caught on the screen. Okay. And another thing that you have to remember is regarding what happens if the object is very, very far. Let us talk about a concave mirror. You remember the diagram? You remember the ray diagram? Concave mirror, right? And rays are coming from very far off. What will happen? Is it converging or is it diverging? Converging. It is meeting there. Correct? Therefore, a concave mirror is a converging mirror. Correct? But if you look at a convex lens, what is happening to a convex lens? Sun rays are coming. Is it converging or is it diverging? Convex में क्या है? Converging. Here it is converging here. Correct? It is a converging lens. A convex lens is a converging lens. A concave mirror is a converging mirror. That you have to be careful. Yeah, which means to say I'm once again emphasizing about your ray diagrams. Be very particular about your ray diagrams. Because in many times when you see the word problems, they will just write an object which is kept at 2f2. Okay, and the image is also of the same size. So you should remember when is it going to be of the same size. Correct? Did you understand what I am saying? If it is kept at 2f2, if the object is kept at 2f2, image is also formed at the 2f2. Correct? Similarly in that case. So you have to remember those ray diagrams and in respect to that when we talk about the sums. Come. What about your power? What is the formula here? P is equal to what? Power is only small lens. Okay? 1 upon F. So F always has to be in meters. It always has to be in meters. And what will be the unit for power here? It is diopter. Okay. So if you say if power is 1 diopter, it means that your focal length of the lens that is taken is 1 meter. Okay, it is equal to 1 meter. That means 1 diopter is 1 meter inverse. Did you understand this? 1 diopter is 1 meter inverse. Okay, it is the reciprocal of the focal length. So therefore it is that. Okay, right. Coming to the page number 158. I want a few questions to be done. Some of it is very easy, you can do it for homework. Okay, some you can do it here. The next question, there are some there. Define 1 diopter of a power of a lens. See this question. You have already done this. I know. You have done this. Page 158. Okay. What will you write for 1 diopter? 1 diopter.
Whose focal length is 1 meter.
Yes, whose focal length. Okay. Yeah, diopter of a lens is whose focal length is 1 meter. Or you can also write it as 1 diopter is 1 meter inverse. Okay. Next one. Can we do the next one? See the next one. A convex lens forms a real and inverted image of a needle at a distance of 50 centimeters from it. So which is the object here? Have you done this? No, we have not done it. Okay. Which is the object here? The needle. Okay. So let's say this is a convex lens. We have kept a needle here and it is forming a real and inverted. So obviously it is formed somewhere here like this. We don't know what it is. Where is the needle placed in front of the convex lens? If the image is equal to the size of the object. So at which position is that? Ray diagram. Turn the pages and see. Focus. Turn the page and see. The size of the needle should be equal to the size of the image. Turn the pages. Search for the ray diagram.
And focus.
Yes. Where? Here it is F1 to F1. So if you are keeping it at 2 F1, okay, this is your image is going to be formed here. Did you get the diagram here? Did you get a diagram like this? If size is 3 centimeter, the image size will also be 3 centimeter. So where is the image? Where is the object kept? It is kept at 2 F1. Is that okay? See here they have not told you, but they have given you a hint as to the size of the image form. Also find the power of the lens.
Minus 0.5.
Okay, you get power is equal to. This is how much. What is this? How much have they given here? 50 centimeters. So this is your F. So F is equal to 25, correct? So P is equal to 1 upon F, correct? So F is 25 centimeters. So P is equal to 1 upon 25 divided by 100. So that was 4. Okay, so that's what we got. Did you understand? Either which way. You can also write it as 25 upon 20 upon 100. So 0.25. Instead of writing 0.25, I directly put it that way. So that gives you 4. What? 4 D diopter. Positive or negative?
Negative.
We are using a convex lens. Convex lens.
Negative.
Positive right now.
Convex means
Convex is
converging.
what we are converging. Positive. Okay, so because this is positive, isn't it? F is positive, right? So this is going to be 25 centimeter. So therefore it is positive. Do that now, come on. Write it down in your notebook. Okay, come on, write down. Page number 158. Come on, everybody do it. Page 158. Distance. What is given to us? Okay. Object distance is given. Is 50 centimeter. Your object happens to be a needle. Right? And another hint that they have given you is what? The size of the image is the same as the size of the object. That's a hint which they have given you. Size of image is equal to the size of object. Okay. What should we find? Required to find? We just have to find out the power. That's all. How are you going to show the steps for this? How are you going to reason out? Okay, so your solution write down. If the object is placed, if object is at 2F1, then the image is at 2f2. And it is of the same size. Therefore, your focal length, okay, is equal to half the radius, r divided by 2. Next, you are asked to find out P. P I have shown you here how to do it. We know how it has to be done. Okay. This is your question number 2. And write on the page number there. Okay. Let's do third sum. Do the third one.
Now, P is equal to 1 by 1.
Okay, find the power of a concave. Concave is what? It's negative. Correct. That is simple. Let's look at the exercises. Okay. What happened? You're not taking it up. Anyway, you do it. What about you, Vega? He was dreaming, looking at the board for 5 minutes. That's why I left it out. Not to be alert. Okay, you are going to do it on your own now. Everybody has finished, you are still sleeping. So I did not tell you anything to do. Done, finished? Right? I help you, don't worry. Okay. All of you look at these exercises now. Okay. Boys. Exercises here. Okay. Which one of the following materials cannot be used?
Clay.
Clay.
What about water? Can it be used for making a lens?
Yeah.
Yes.
Yes.
What you transparent water, you put water in it, then definitely yes. Glass, yes. Plastic, yes. Plastic, transparent plastic. Provided they mention it's a transparent. Here obviously it is clay because all others are. We are assuming the plastic that they mentioned is transparent. Second one, image formed by concave mirror. Remember what is the confusion? You want to work the fan or you don't want the talking mind heads. Image formed by concave mirror is virtual, erect, larger than the object. Where should be the position? Look at the ray diagrams. If you are not yet thorough with the
Pole and
it should be within the focus then. It should be within the focus. Yes. Between the pole and the principal focus. Okay. Next one.
Measure an object be placed in front of a convex lens
To
to
get a
get
real
a
image.
real image of the size of the lens.
What is the hint here? The size of the object has to be the same size. So it should be yes, twice the focal. That means it is F and 2F. Obviously, it has to be kept at 2F1. Very good. Next.
The spherical mirror and the thin spherical lens have each a focal length of minus 15 centimeter. The mirror and the lens are likely to be
The mirror is convex and the lens is concave.
Both of them have negative.
The mirror is concave.
Mirror is concave and the lens is
convex.
Spherical lens. The lens should be concave. Okay, then the focal length will be. See, if it is a convex one, it is going to be positive. What lens I'm talking? So the lens has to be a concave lens, and here a convex mirror. Here it is both. Okay. Which one?
Either plane or coordinates.
Fifth one. Okay.
Either plane or
Yeah, the fifth one. Come to the fifth one.
CC.
either plane.
No
or-
matter how far you stand from a mirror, okay, your image appears to be, it is always erect. Plane mirror, yes,
Concave or convex.
And
Convex lens
convex.
of lens focal
and
point.
convex mirror. That's
Either
true.
plane or-
So, option, if an option is given as either plane or convex, that is correct. But we have to be careful, children, here, they have given only plane mirror, only convex, it's definitely not plane and convex, it can be either of them if the choice is given, okay? You have your textbook with you? That's yours, okay. Next one. Are we using a convex or concave? Reading class.
Concave.
Small letters. How can we use a concave? Do we use a concave or convex?
Convex.
Magnifying glass, no? It's a magnifying glass, so it's a convex mirror, lens, convex lens. So there are two options. One convex lens is 50 centimeter, another one is focal length of 5 centimeter. Which one will you use? Yeah. If you're, yes, 5 centimeter. If the focal length is small, then P will be more. You remember that? Because it is inversely proportional, yeah. So if the option is given, obviously you should take one with a smaller focal length, because the power should be more. Now this is a ray diagram to show the image formed in this case. Okay. We wish to obtain
And erect.
an image, yeah, using a concave mirror. So what happens?
We did this.
Headlight is the diverging mirror.
Headlight
Headlight.
mirror.
Yeah.
Concave.
Converging, yes, so
See, for headlights, you want a parallel beam. A parallel beam, that means the bulb has to be placed in such a way that you're getting a parallel beam. That is concave. Mirror.
Mirror.
Okay. Now I have put a tick mark for some of the sums which are referring to lens. Lens, did you put a tick mark there?
Yes.
I've already marked it for you. 9, 10, 11,
12.
no, 12.
12.
11, 16 and 17.
16 and 17.
All of them are for lenses. Okay, we should be able to do it.
7, 12, 13, 14.
Yeah. So can I give it to you for homework?
We did it.
All.
Already done. Yes.
How many of you have not done? Please be honest about it.
Done.
Can I check it in your books right now?
Yes.
Yes, 7, 9, 10.
We did it in the class.
I know many of it I've finished it. Partly I've done. I said the rest of it you just have to finish it up. If it's not done, please do it. I'm giving you one more day.
Concave after the whole exercise. Whole NCERT exercise.
Not finished. I've completed all that. Okay. Then try to do as many questions as possible from your model. Fine. So today I'd like to start off with your the next chapter. Chapter 11.
In solar furnace, which type of mirror will be used?
Okay. Huge concave. How difficult is this chapter? I'm sure they have started off in your school. Very.
No, we haven't started.
Okay, good. If you have not started, it is very good. Started? Okay. Right. Almost done. Okay, fine. Let's start with some of the basics. You don't look at your textbook right now. Electricity, I'm starting off with electricity.
Schools have started.
Yeah, that's what I said. Some of the schools they might have started, and I'm sure it is there for your exam coming up in August or something of that sort. Right? Are we ready? Are we ready?
Yes, ma'am.
Okay. So first of all, let's try to understand what is the importance of electricity. Right now, you have taken things for granted, you're sitting very comfortably. Okay, but the moment we have a power shutdown, that is when we.
Last year, ma'am, we would experience that.
I was there, I know that it was so bad, we had to cancel our class. Okay, going up and down the lift, it was so comfortable.
Once we sat like.
I know we sat outside and we had a class, imagine. That was also there. So yeah, these are small things that we realize that when electricity is not there, it can disturb our life. But if you look at a major scale, many of our life supporting systems also run by electricity. People who are in hospitals, okay, dialysis machine. People may be supported on a heart-lung machine. What happens in an operation theatre? Suppose the surgeon is doing operation and suddenly there's no power. Okay. So obviously we have to think about what are the different ways by which we can substitute electricity. That's what we are talking about, generators. Okay. So in this chapter basically we are talking about what are the basic aspects of electricity, and at the same time we are also talking about the discovery of what was electricity. So right now you people already know in your earlier classes that when we talk about electricity, there's something which is known as static electricity, and what we are going to be talking about is current electricity. This is what we will be talking about.
Static is also a force, right?
Yes,
Is also a force.
it's static electricity itself, not static force. We're not discussing a static force. We're talking about static electricity. Like for example, you're taking a plastic comb, okay, and you're rubbing it. Yeah, and then maybe you can put it on small pieces of paper, it can attract it. So that's nothing but static electricity because of difference of charges. But now we are talking only about the current electricity. Okay? So when you talk about current electricity, basically it tells you that something is moving. Right? Moving. So there are charges which are moving, and that is responsible for current electricity. Now we have noticed that these are the wires which are helping us to have the movement of electricity. So instead of first directly talking about what is electricity, let's talk about what is known as a simple circuit diagram. So when you talk about a circuit, obviously it shows that you require a path for the movement of the electrons, okay, movement of the current charge. Suppose I say that this is a battery, right? This is your positive terminal and this is the negative terminal. Something funny. That's good. Very good. If you've already tried it, that's nothing but standing right. Yeah, that's perfect. That's good. Part of it is also sticking onto the layer. That's because they have charges which are shifted. Like this. Okay, so the charges are right. Okay. Let's say I have a bulb there and I want the bulb to glow. So obviously I need to have a few more things. What should I have? You are going to have a wire. Okay, so you are going to have a wire.
Switch.
Okay, why should I have a switch?
On and off.
Yes, obviously I need to switch it on and yes, yeah. So obviously I need to have. Okay. That means the circuit can be either closed circuit or it can be an open circuit. If I say it is a plug key, I don't know, many of you might not have seen it, but if you go to the lab, this is how it actually looks like. So there's a small plug and there's a key inside. So when you put it, that means there's a connection on either side which gets completed. So this is an open key and this is a yeah, it's closed, right? That means it is allowing the current to flow. So the moment we plug it, we find that there is this, okay, the light is giving the glow. What happens if the wire is cut?
Circuit is working.
Yes, the circuit is broken, no? There's no continuous path. So when we talk about an electric circuit, it means it's a complete path for the flow of current. The definition, what is an electric circuit? An electric circuit is nothing but a path for the flow of current. And when we talk about a conventional current, the current always flows from the positive terminal to that of the negative terminal. Remember that. Okay. I'm talking about conventional electricity. So it is always this way. Now I have a gap here. Okay. I'm giving you, let us say, give me a pencil. Is that a pencil? No, no. A regular pencil. Good one. Auntie, that's it. I'm giving you a pencil. Using this pencil, can you make that work?
Yes.
Right?
Wood is not a good conductor.
Wood is not good. Why did you say
It's
this?
a white graphite is a good one.
Penny, go ahead. But where do I have a graphite?
In the lid.
Yeah, but only in one side. So
We can sharpen it from the other
very
side.
good. Excellent. Did you understand? Here, this is graphite. It's nothing but carbon. You will learn a little more in the carbon lesson because we are talking about electrons of carbon. I know. I wish I can take it. Anyway, here we have graphite, which is a very good conductor of electricity. So what we do is sharpen this side so that the graphite part of it is exposed and we connect it here. Do you understand? So the electricity flows through and through here. You can do that. Have you followed? So there are certain substances. Wood, of course. If you are using wood, it is not going to glow. But if at all there's a pencil like this which is given, which has got a graphite in it, we say it is lead, but it is not lead. Okay? What is the chemical composition? It's nothing but graphite. It's a very good conductor of electricity, right? So we say that you can definitely use certain substances which can help the electricity to flow. What if I'm giving you a rubber piece? If I put a rubber piece here, will it glow? Right? It does not conduct. Very good. Wood? No. What happens if I give you a safety pin?
Yes.
Yes, it's a metal, definitely. Okay, instead of this, if I put a safety pin like that, it will definitely. Okay. What about silver?
Yes.
Very good, very good. Okay. Gold? Yes.
Yes.
But we use silver and gold wise copper.
Copper.
Copper or aluminum. Mostly we use copper or aluminum. Obviously because silver and gold very expensive. Although it was short up. You know how much is it? Exactly. Yeah, it's short up like it. But all these precious elements like gold and silver are used in your electronic components. That's why they're expensive. Do you understand? All our electronic circuits, okay, they have got a small amount of these precious metals because they're very good conductors of electricity. Right? So therefore they say that is why you need to recycle these components once again. Coming back here, now we have understood that the substances can be of two types. Okay, what are the two types? One which is a good conductor of electricity and another substance like rubber, wood, plastic, something that is a bad conductor. Okay, what is a bad conductor called? Insulator. Very good. It's an insulator. That's why whenever somebody is working with any repair work, the first thing is that you should have your footwear which is made of rubber. Okay, or even the pliers or whatever it is. You notice that it has got an outer covering, right? So basically these are substances. So based on what are we conduct? Sorry, what did you say?
I not know that's why we have rubber handles on them.
Yes, that's basically good. If you are having any pliers which is made up of metal, you will catch shock. So that's the reason why they give you. What about the human body? Is it a good conductor, bad conductor?
Yes,
Good conductor, right?
We have electrolytes.
Excellent. Okay. So we have, yeah. What is a human body? Nothing but blood. Blood is made up of plasma, RBC, WBC, etc. And also a lot of electrolytes. Na plus, Cl plus, potassium, calcium, etc. Okay. So human body is a very good conductor of electricity. But at the same time, you should make sure that the circuit is not complete whenever you are handling. So that's why we wear our rubber jumpers or the gloves which is made up of rubber. So that it is. Are you okay with this? So what are the two types of materials? A good conductor and something that is a bad conductor, which is also known as an insulator. Are we good till here? Right? Fine. Once we have understood what is meant by an electric circuit, we can now talk in terms of what is meant by current electricity. Okay? We talk about electric potential. Always remember water and electricity. They are very, very similar. Suppose I say I'm going to a place like Lonavala after the rainfall because I want to see the waterfall. So what's happening to a waterfall? This is how your water falls. Do I get a waterfall in Vashi? Why?
There is no mountain.
There's no mountain. So what is essential for a waterfall?
Height.
Height. So the greater the height, the greater is the waterfall. Here what are we talking about? We are talking about height. This is height. The greater the distance between one level and the other level, the greater will be the waterfall. Think of electricity something like a waterfall. Okay? But now we are not talking about height. We talk in terms of electric potential. So how does electricity flow? It's always from a higher potential to a lower potential. But we are not talking about height now. Okay? So when we talk about a battery, suppose this is my battery, and this is the positive terminal, and this is the negative terminal. Okay? Battery, you always see, there's a plus sign and a minus sign, positive one. What did I tell you? Electricity flows from the positive terminal to the negative terminal. Correct? From the positive terminal to the negative terminal. So which is at a higher electric potential? Is it the negative terminal or is it the positive terminal? Are you sure? Yes or no? Yes, that's correct. Because when we say electricity flows from the higher potential, which is lower potential, obviously it is the positive potential which is at a higher potential, and this is the lower potential. Is that okay? So what is the function of this battery? What does it do? Okay, you're right. Suppose you're using it for your TV remote. Okay, it will run for a couple of months, then you'll have to discard it. Why does he have to discard it? Because? Okay, so there's something inside the battery. What is it? Lithium. Lithium. You are talking about lithium. Do we use lithium batteries every time?
Yes.
No, we use a normal, ever ready battery or whatever it is. Why is it that we are using? And why do we throw it up?
It's chemical batteries.
Yes, there are chemical reactions which are taking place. There are chemicals here. Because of the chemical reactions, there are electrons which are produced. Okay, so those electrons, obviously the flow of electrons will start once the charge, the chemical reactions get over. But sometimes we also use a rechargeable battery.
Yes.
Do we have a rechargeable battery? What do? We plug it on. What's happening?
It's charged.
Okay. So what are we talking about? In this case, in an ordinary ever-ready battery, what are we talking about? So this is a higher electric potential to a lower electric potential. Right? We have seen that positive and this is negative. Always remember from a higher to a lower. For you to remember, I have drawn this waterfall. Otherwise, it's not necessary. Once we get this idea in our brains, then it is perfectly alright. Have you followed? There's no waterfall, there's no difference in height. But for you to remember, I have drawn this. Is that okay? Now, I'm talking about this battery. Imagine that this is an ever-ready battery. Correct? Now, is a change of the energy taking place. Suppose I put this in the circuit like that. I said that this is the cell and something like I'm talking about a bulb and this is a continuous electric circuit. What energy is getting converted into what energy? What is present here? Correct. Chemical energy is getting converted into electrical energy, and what is getting lighted up? Here it is a bulb, so it is light energy, isn't it? Suppose I have a toy here which is moving. What is it that? Mechanical energy. Correct? Did you understand? Suppose instead of this I have got something else. Let us say I have got something that is getting heated up. So what is happening? Heat energy. So there is nothing but a conversion of energy which is basically taking up. Are you okay till now? Yeah? Right. Leave 2 pages here. After every chapter, I want students to leave 2 pages because some interesting questions I keep on discussing. You can keep writing. Write your chapter. Today's date. Current electricity.
Ma'am, I have this doubt. We get cells from the market. So they are packed like months ago. So is there like cases where it does not cannot be used for
Discharge. Right? Yeah, sometimes it happens. I mean, if it is sealed, it's all right. But sometimes if it is kept, that's why it's always in a sealed thing.
So it's like it's always producing.
It's not, unless of course this is closed only. This entire circuit has to be closed. If it is in a packed thing, then obviously it is not getting used up at all. Got it, na? Okay. Shall I start? First one is what is an electric circuit? Right now. A continuous and closed path. A continuous and a closed path of an electric current is called, I'm repeating, a continuous and closed path of an electric current is called an electric circuit. It's here, right here. See here.
Electric circuit.
It's called as an electric circuit. Underline it in your textbook. Second point that we have discussed right now. Before we do that, 2 types of substances. A substance, put a bullet point. Substance, and in bracket you write down silver, gold, copper, aluminium. These are all metals. What is the next section here? Non-metal. Give me one non-metal. Graphite. Just now we have seen. All these are 4 things are metals. Okay. Graphite is non-metal. Yeah, graphite is non-metal. So that's why I'm asking you to mention it. Okay, silver, gold, copper, aluminium, and graphite are good conductors of electricity. What will be the symbol for graphite? What is the substance? What is that? What is that lead thing? No need to. Huh? No. Carbon. It's nothing but carbon. What is carbon? C. Okay. What is silver? Ag. Au is what? Gold. C is copper. Aluminium?
C is copper.
C is copper. Yeah.
C is carbon.
Cu. Copper is Cu. C is carbon. What is air?
Aluminium.
Aluminium. Okay. Okay, so all these are good conductors of electricity. Have you made a note of it?
Germanium is also metal.
No, it's a metalloid. Germanium is a metalloid.
So do metalloids conduct electricity?
Some of them, they have properties of both metals and non-metals. That's why they're called as metalloids. Is that okay? Then, write down insulators. Next bullet point, insulator. A substance that does not allow the flow of current. Is an insulator.
Hello?
It does not allow the flow of current. Does not allow the flow of current. It is an insulator. Example. Example.
Wood, rubber, plastic.
Correct. Right now. This mention. Okay. Now here we talk now about how do we express electric current. Okay. Did you notice we are using the flow of electric charges, and there's also another word which is rate. If it is rate of, you remember what we have discussed in the 9th standard? At the moment we say it is the rate of, that means it's with reference to time. So we are talking about the flow of electric charges, which is nothing but charges which is in the form of, okay, you have electrons which are flowing, and that basically is nothing but your current. Okay, so I is equal to Q upon T. So now here in this lesson, what we need to know is there's a lot of terms which are meaning for different, okay, the physical quantities that we discuss it a little later. Now here, the last paragraph. How do we express? Will we read?
How do we express electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time.
Underline that. I'll try to read those words carefully. Okay, it is express the amount of charge flowing through a particular area in unit time. Did you notice there's a factor of time? Okay, and it is flowing, it's not static. Next.
In circuits using,
No.
in other words, it is the rate of flow of electric charges.
Underline that. Underline that also. Okay.
In circuits using metallic wires, electrons constitute the flow of charges. However, electrons were not known at the time when the phenomenon of electricity was first observed. So, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. Conventionally, in an electric circuit, the direction of electric current is taken as opposite to the direction of the flow of electrons, which are negative charges. If a net charge,
One minute. Did you understand the last few lines there? What did we talk about? We spoke about the direction of the flow of electric current, which is always from where to where? Always from the positive terminal to the negative terminal. Okay, if you are using a battery or so, whatever it is. What is the positive terminal? Is it higher potential or lower potential? Higher. From a higher electric potential to a lower electric potential. Write down these two sentences in your notebook because I don't want you to get confused later. Okay, so the last thing that we have spoken about is what is an insulator and what is a good conductor. Next bullet point, we have also written about, okay. So, electric current is expressed as current is expressed by the amount of charge flowing through a particular area in unit time. There's another way to express it, write on that also. Or it is the rate of flow of electric charges. Is that okay? Have we underlined all these lines here? Is that okay? Right. Go on to the next page. We are talking about electric charges. So when we say electric charges, that's nothing but we are expressing something about the charge which is present on the electrons, right? Electrons, we know that it has a negative charge. So obviously one electron obviously has got a very, very small charge. So we need to have a huge amount of electrons which need to pass in order to give us a charge of 1 coulomb. So what is 1 coulomb? Coulomb is nothing but the what? What is 1 coulomb? It is the unit of charge. Is that okay? Right? If the net charge, so what is Q? Now this is where we need to be careful about. I'll give you a table next time.
Now the symbol of charge is Q, right?
Q, but it is unit will be coulomb. Okay. So we have charge, which is expressed as Q, and the unit will be coulomb. C. Okay. 1 minute, children. What I'll tell you is take a fresh page because we have got lots and lots of such things coming. Okay, so take a fresh page, make a table there. Today I have just given you charge, which is Q, and unit will be coulomb. What? Wait. We'll do this. You will understand. Okay, and there are about 10 of them coming up here. There are at least about 10. Okay, so we'll talk about V, W, X, Y, Z, everything. Okay, at least half a page you will require. Wait, no, don't get confused. Okay, put it up here. Okay. If a net charge, ready? The next page. If a net charge, I'm talking about charge Q, okay, flows across any cross section of a conductor in time t, then I'm just reading it out from here now. Okay, in time t, then the current I through the cross section I is equal to Q upon T. Now this is very interesting. We are talking about I, which is equal to Q upon T. Right? What is I here? What is I? I is
Can you explain the meaning of cross section?
I tell you, I'm not yet done. That's it. I is current. Right? So that is the first one. Second, we talk about current, which is I. And the unit will be ampere. In physics, you will find that many of the units here are after the scientists, in order to honor the scientists. Like for example, Newton, okay, Ohm, Pascal, all of them are okay, scientists. So now, and of course, there's another one which is T. T is okay, everybody knows about time, T, and this is going to be in seconds. So as and when we come across these alphabets in a formula, we try to see what is meant. Now there's a cross-sectional area. What does it mean? Suppose this is a wire. Look at me. Okay, this is the wire and the electrons are flowing through. In a cross-section, suppose you cut it. Ushita, suppose you cut this. you get a cross section. Did you understand? You're cutting it, so it looks like a small tunnel. So imagine all those electrons are moving through the tunnel. Okay? If there is a free flow of those electrons, then it's a very good conductor. Okay? But if there's some kind of a resistance inside, then obviously it will be a poor conductor, or it may also be an insulator. Have you followed? Now, how will you remember this? This is one of the first formulas that you will. Do you know this alphabet? Quit India movement, you must have done in history, etc. Did you see this? Q, I, T. If you rearrange, you get it as Q is equal to I and T. So it's an easy method to remember. How will you remember? Q is equal to Quit India movement. U is not there obviously. Q, I, T. So you can rearrange this. If Q is given, T is given, you can find out I. Or if I and T is given, you can find out Q, and so on and so forth. Is that okay? So that's the first formula that you write. Next. I want you to write down the definition. Continue with your definition. Be careful about this table. Don't write anything in the table part of it. Okay, that will fill it up. Write down. Write down. If a net charge Q, first two lines of your textbook, just make a note of it in your of the textbook here. If a net charge Q flows across any cross-sectional area, right, boys, come on, write down fast. Cross-section of a conductor in time t, then the current is equal to Q by T. First two lines, come on quickly. From next time onwards, everybody is going to get your own textbook. Please don't depend on others.
Definitely.
Write down the formula also. I is equal to Q for T. Now will you remember? Wait. Now you will not forget it, right? Okay. Now, so the next paragraph. Hurry up, boys. I can't keep waiting for you. Okay. SI unit of electric charge is Coulomb. I've already put up there. Okay. Charge is given as Q, but its SI unit will be C, which is equivalent to the charge contained in nearly 6 into 10 raised to the power of 18 electrons. See the numbers? You require so many electrons which is passing through to give you one charge of 1 coulomb.
What is the SI unit?
SI unit. For what?
Electric charge.
Coulomb. Okay. The next slide. Manish, read the next slide. The electric current is expressed.
And then
There's so many of them.
the electric current is expressed by a unit called
Ampere.
ampere.
He was a French scientist, Ampere. Okay.
Named after the French scientist and
1 minute. Girls, 1 minute.
Yes.
Let's get back. I don't want any giggling or anything, please. Let's concentrate. Or we stop. There are only two things. If we want to concentrate, we have to really concentrate. We can't have laughing and talking and having reading. Are we ready? Just a few minutes more. I think we are on almost time. Yeah, maybe 1 minute. Come on. Just finish off this paragraph. Right. French scientists, continue. Andre Marie Ampere. Anish, come on.
Ma'am is making me laugh.
here.
Map was for average.
Okay.
One MPS is constituted by the flow of one column.
Kulu. Okay, perfect. We continue it. Complete your homework for life. Whatever you have missed out, you write it down. Don't dream in the class next time. Second year.
उसे जमा निकाल के हंसना नहीं मैं आईडी कार्ड ढूंढूंगा
नीचे देख
नहीं है वो है